Welcome back again to this edition on the tutorial. We are still continuing inequalities and graphs. This is part 2. In this question, it says find the set of values of s for which s squared minus 7s plus 10 is less than 0 and 3s plus 5 is less than 17. As we know, we will solve this systematically. But in the first place, we will tackle this one. And then secondly, we'll come back and tackle this one. And then analytically, we compare, the values of s where overlap will occur between this and this inequality and that inequality. Just as like the previous tutorial examples, it is almost the same. So at this time, let us pick up this one. So I'll say the solution. Good. This one is s squared minus 7x plus 10 is less than 0. We know that this one is equal to f of x, which indicates that f of x is less than 0, which is very important. F of x less than 0 means that the values of x below the x-axis are the values that we are looking at. The values of x below the x-axis are the values of x that we are looking for. So if you try to factorize this quadratic equation, as we've already done factorization in the previous lessons, it is not something that we are going to repeat it again in a long process. So if you pick up this quadratic equation, which is s squared minus 7x plus 10, if you factorize it, you have x minus 2x minus 5, which implies it's less than 0. So this curve, this curve is, if we are going to scale this curve, we can know that the factors of x when x is equals to 0 are s equals to 2 and s equals to 5. So the graph thereof will be something like this. In which case, this one will be 2, and this one will be 5. And this is the y-axis, and this is the x-axis. So we are after the values of x that, that is below the x-axis, which implies is 4. Let me continue from here. For f of x less than 0, then it will be this portion of the graph. So it will become something like this. This portion of the graph that we are looking for. The values of x below the x-axis. This is f, y equals to f of x. So this is 2 and this is 5. So these are the values of x that we are looking for. So sorry, this is 5. So this inequality, s squared minus 7x plus 10 is less than 0, is x is 2 less or equal to x less or equal to 5. Or I can say that in this one it will be 2 less than x less than 5 is the appropriate inequality. I'll call this one equation alpha. And then with this inequality, this inequality is valid under this domain. So we will tackle this one. If we have finished this part, and we are going to tackle this one. So picking the 3x plus 5 is less than 17, we have 3x plus 5 is less than 17, which is also no different from 3x is less than 17 minus 5, which is 3x is less than 12, which is x is less than 4. Very good. I'll call this inequality equation beta. Now, we are going to draw a number line, and we are going to place all these inequalities inside the number line. So this is how we are going to do it. So let's have this one. See on the board if you can see it. Yes, you can see clearly. And let's assume that here is 2 and here is 4 and here is 5. And this is the x-axis. We are doing it. We are calibrating the numbers on the x-axis corresponding to what we have here: 2, 5, and 4. 2, 5, and 4. Now, look here. In this inequality, it is between 2 and 5. So this one is this one and 5 is that inequality. Good. That is 2 less than x less than 5. Let me see the board, whether you can see it properly. Yeah, you can see it properly because I can see it on my screen here. If I can see it, it indicates that you can see it as well. So this inequality is what we have here. This is 2 and this is 5. Now, let's go to this inequality. This inequality says that, x is less than 4. So it is here 4. X is less than 4. It goes this way. Good. So this is inequality x is less than 4. Good. Now, we are going to find the overlapping space or the overlapping region. The overlapping region is going to give it the set of values of s for which these two inequalities are valid. We observe that the overlapping region is this region. There's an overlap here. This is an overlap. In this overlapping region is 2 and 4. which indicates that is less than x is less than 4. This is the overlapping region. The overlapping region gives these sets of values of x for which these two inequalities are valid. Therefore, these two inequalities are valid within this region, the overlapping region. So when the question says that find the set of values of x for which x squared minus 7x plus 10 is less than 0 and 3x plus 5 is less than 17, then that set then the set of values for which these inequalities are valid is this one. This is the overlapping region. This is what he is looking for, and therefore this is the answer, the overlapping region. So in your conclusion, in your question, you can say that as I dictate, I would like you to write them down. The set of values of x for which these two inequalities, this one and this one, are valid is 2 is less than x is less than 4. Probably I can borrow the other session and write it down, as well. So I will say that the set of values you can see it. So I will do it at the other side. Leave this one. Therefore, the set, can you see it? Yeah. Of values of x for which the given inequalities are valid is 2. Can you see it? Yeah. It's less than x is less than 4. Can you see it? Yeah, you can see it. Yeah, then that is that part of the question. We've done with it. So when the question says that find a set of values of x for which this inequality x squared minus 7x plus 10 is less than 0 and 3x plus 5 is less than 17, that set of values of x is this one. So that's the answer. Now, take your time to copy it, as I'm going to stand at this side to make the board more clear for you to copy. And then I'll come back again with different questions. And you can pause the video in the meantime. As you can pause the video as you copy it, and I'll come back again with another question. Thank you. When I come back again, And this is another question that we want to consider. It says, find the range of values of k for which the equation s squared minus ks plus there's k plus 3 in a bracket equal to 0 has no root. If I may repeat it again, I say that find the range of values of k for which the equation s squared minus ks plus k plus 3, which is in a bracket, equals to 0 has no root. This is not a big deal at all. Solution. Any given quadratic equation of the form ax squared plus bx squared plus bx, plus bx plus c, let's say y has no solution when b squared is less than 4ac. That is the condition. If you have any given quadratic equation and you compare the coefficients of a, b, and c, and you find it out that b squared is in fact less than 4ac, then it indicates that that quadratic equation has no solution. What's the meaning of this? This is also not a big deal. Pick up the equation from there. We have s squared minus kx plus k plus 3. Comparatively, if we compare to the general quadratic equation, we can see that ax squared plus bx plus c equals 0. In which case, this equation, comparing the coefficients on both sides, we can see that a equal 1. Comparing the coefficient of s squared, we see that a equal 1. Then b equal minus k. And we have c equal k plus 3. Very good. This is some powerful beginning. Then, having got the value of a, the value of b, and the value of c, we can use this equation. Let me call it equation phi. We can use the equation phi and substitute the results of a, b, and c inside equation phi. And then we can see that equation phi now becomes b squared is less or equal to 4ac. Now, what is b? Yeah, b is minus k square less or equal to 4. What is a? A is 1. And what is c? C is k plus 3. Good. Then we have squaring a negative number. That number still becomes positive. So we have k squared is less or equal to 4. Then k plus 3, which is no different from k squared is less or equals to 4k plus 4 times 3 is 12, which is k squared minus 4k minus 12 is less or equals to 0. This one becomes f of k, and we observe that f of k is less than or equal to 0, which implies is f of k, the values of k that we are after will be those values below the k axis. Those are the values that we are going to consider. So in the first place, we note this, we note down this important factor, and then we come back to the quadratic equation, which is this one. Factorizing this quadratic equation, where is the space? There's a big space there. So this quadratic equation, k squared minus 4k minus 12 is very much identical to if you factorize this one, it becomes k minus 6 k plus 2 is less or equals to 0. Or you can say that, yeah. So if we are going to plot this graph, which is going to be like this, the factors of k, when f of k equal to 0 on the k axis, this is y or f of x, and this is k axis, and this is the origin. Okay, so we have here minus 2 then. We have here 6. So the quadratic curve is going to be something like this. But because f of k is less than 0, we'll only consider the lower portion of the curve. In this case, this one has to go. And this one has to go as well, because f of k is less than 0. So these are the values of k that we are looking for. And these values of k is minus 2 is less than k is less than 6. Let me look at my screen if you can see it. Oh yes, you can see it. Then that is a fantastic job. Now, which means we are done with the question. Find the range of values of k for which the equation s squared minus ks plus k plus 3 as a constant equals to 0 has no root. Then this is those values, the range of values of k that is asking for. Then we are done. That is just a simple analysis, and very plausible. Then let me look at my screen. Yeah, you can see everything is right there. Yeah, then that question is finished. Then the next question, we'll consider another question quite similar to this one. But in the meantime, I would like you to take your time to pause the video and copy everything as you see on the board. And you can see that this time we are moving very fast. This is it, as you become mature student. Yeah. Now, take your time, copy everything, and then we'll come back again with another question in consideration. Thank you. Welcome back again. This is another question. Find the range of values of p for which the roots of the quadratic equation p squared plus px minus 2 equals to 0 are real. Solution. We are finding the roots of this quadratic equation as they are said to be real. So, I mean, any given quadratic equation of the form y equals to f of x equal a squared plus bx plus c equal to 0 has real roots when the discriminant b squared at this time greater or equals to 4ac. I'll call this one equation 5. Then we get back to the quadratic equation that is given. So we were given p squared plus px minus 2, very much identical to as squared plus bx plus c equals 0. Comparing the coefficients of x squared, we can see that a is equal to p. Comparing the coefficients of x, we can see that b is also equals to p. Comparing the constants on both sides, we can see that c equal minus 2. In that brevity, we bring everything that we see here, we are going to put it back into the equation 5. In such case, equation 5 becomes being b squared greater or equals to 4ac now becomes, what is b squared? B squared is p squared greater or equal to 4. And what is a? A is p multiplied to p. And what is c? C is minus 2. In which case we have p squared is greater or equal to minus 8p. We can bring this one to the left hand side. Be negative at the right hand side. Once it crosses over the frontier or the border, it becomes positive. Under such condition, we have p squared plus 8p is greater or equal to 0. Factorize p outside, we have p plus 8 greater or equal to 0. But remember, this one is f of p. So we can see that we have f of p is greater than 0. Which implies is the curve that we are going to sketch, we will look after the p values above the p-axis. Very good. But if you have such a graph, let me see whether there's space over there. Not so much. Then let's make good use of this this side by using different good popping color. Let's use this color. This is f of p axis, and this is the p axis, and this is the origin. If you pick up this equation, you can see that the factors, the root of this equation, when f of p is equals to 0 on the x-axis, we have p equals to 0. This one, we have p equals to minus 8, which should be that one. So let's say minus 8. Here is 0. Good. So the graph that we are going to consider is going to be something like this. But because f of p is greater than, 0, we will consider only the upper portion, which implies that this one goes away, vanishes. So this is it. And you can see that here we have x or p is less than minus 8. And here we have p increases as the curve goes this way, decreases. Good. And as the curve goes this way, this one becomes p greater than 0. Good. So the inequality is such that p is less than minus 8 and p is greater than 0. You see? Yeah. Which implies this. In some cases, you can say that it is going this way and this one is going this way. Here, in this region, is p less than minus 8 from this region going. And from this region going, p is greater than 0. This is it. So the range of values of p for which the roots of this given quadratic equation is equals to 0 are real when p is less than minus 8 and p is greater than 0. That's the inequality that the question requested. Then this is also another fantastic, amazing work. And we will bring it to conclusion. Yeah. Then we are done with this question. At this time, I would like to pray for you. Father, we thank you in the name of the Lord Jesus Christ. Thank you for the wisdom that you've given us and the understanding, and for having wrought such a great and amazing work, wonderful God, within us. We praise you. We thank you for your wisdom, knowledge, and understanding. And we also thank you, wonderful God, for the precious time that you've given us, wonderful God, to have this tuition. I pray for wisdom for your children, wherever they are around the world. Now, the Lord Almighty God, make his face shine upon you, lift up his countenance upon you, and give you peace. Shalom, shalom. God bless you. I'll see you back again in the next tutorial. Have a lovely and wonderful and amazing time. God bless you.